In this video I want to show three different ways of multiplying polynomials. I have two binomials here, 4x squared minus 7 and 5x squared plus 3, and I want to multiply them together. I'm going to show three ways to do this, and if I have time at the end I'll do a trinomial by binomial. So normally when we get rid of parentheses, if we're not going to follow the order of operations, we're going to bypass the order of operations by using the distributive property. So I can't really subtract these guys because they're not like terms. And this 5x squared plus 3 is not, these guys aren't like terms either. So what I need to do is I need to use the distributive property. Now I'm used to multiplying everything on the left by everything on the right. In this case, I'm going to use right distribution. I'm going to take this entire set of parentheses and I'm going to multiply it by 4x squared and negative 7. So if I simplify this, let me circle this in blue so that way it's easier to see. I get 4x squared, and I'm going to multiply that by 5x squared plus 3, and then I'm going to subtract, I have this minus 7, subtract 7, and again this blue, 5x squared plus 3. And now I use the distributive property two times. Here's the one that I'm more comfortable with. Taking this left number here and multiplying it by everything, every term on the inside, and then taking this negative 7 and distributing it to everything on the inside of this set of parentheses. So if I simplify this, I get 20 x to the fourth. Remember that if I have the same base and I have exponents, then I add the exponents, and then I take this 4x squared and I multiply it by 3 and I get 12x squared. Over here I take this negative 7, I multiply it by this 5x squared and I get negative 35x squared. And then I take this negative 7 and I multiply it by positive 3 and I get a negative 21. So let's count how many terms we have, and we're not quite done yet because we need to simplify this, but we have 1, 2, 3, 4 terms. Most of the time our terms are separated by addition and subtraction signs. So we have 1, 2, 3, 4, and then when I simplify this a little more, I see that this guy right here and this guy right here, those are like terms, so I can combine those. 20x to the fourth. I add these coefficients and I get negative 23x squared minus 21. So this turns into a trinomial, and this is a quartic trinomial. Now let's take a look at what we just did. Let me rewrite this. 4x squared minus 7, and then I'm going to multiply that by 5x squared plus 3. Let's take a look at what we just did. We took this 4 here and this 4x squared and we multiplied it by 5x squared. Overall, that's what we did. It took us a couple steps to get there, and what I'd like to do is I'd like to go directly from here, bypass that step, and go directly down to here. So I'm going to take this 4x squared, multiply it by this 5x squared. And then the next thing that I did was I took this 4x squared and I multiplied it by 3. So I'm going to take my 4x squared and I'm going to multiply it by 3. So I took this first term and I multiplied it by each term in the second binomial. So in this first binomial I took the first term, multiplied it by every term of the second binomial. And then I took negative 7 and I distributed it to this 5x squared, negative 7 times 5x squared. I might do that in a different color. So I'm again going to take a shortcut on my steps, negative 7 times 5x squared, and then I took negative 7 and multiplied it by this positive 3. So I'm going to distribute that over there. So overall, what I'm doing is I'm taking 4x squared, and I'm multiplying it by everything in the second binomial. And then I'm taking the second term right here, and I'm multiplying it by everything in this second binomial as well. And again, I get these 4 terms. But this was a little bit quicker for me because I didn't have to take that middle step showing my showing this left distribution here. I skipped straight down and did basically I did a little side trick that looked like some left distribution instead. And then again, I have to combine like terms. 20x to the 4th minus 23x squared minus 21. That's what I got before. And it turns out that this is, again, that same trinomial, that quartic trinomial. Now, since I have 4 terms, there's a little mnemonic that people like to do. So this was the first method. And we'll do the second method. It's called the FOIL method. There's this mnemonic, FOIL, and here's what it stands for. First, outer, inner, and last. So it spells out FOIL. And let me copy this down again. 4x squared minus 7 times 5x squared plus 3. It helps me to remember to keep track of my terms. So this is a lot of arrows here and I might get confused. I need to make sure that I end up, if I have a binomial times another binomial, I need to make sure that I end up with 4 terms at the very end. And this is going to help me. FOIL has 4 letters. It tells me exactly what to do. I take my first number and I multiply it by my first number. I multiply these guys together and I get 20x to the 4th. So this is F for FOIL. And then I take my outer terms. Outer, let's see. This is the one on the outside. This is one of the ones on the outside. And this is another one on the outside. So these are on the outside. That would mean that these guys are on the inside. And I get plus 12x squared. I take my inner terms, again, right here. These are my inner terms. Negative 7 times 5x squared. That would be negative 35x squared. And then finally, I take my last terms. This is one of my last terms, and this is my other last term. So my last terms I'm doing in gray, and I get negative 21. And then when I simplify this, I get 20x to the 4th minus 23x squared minus 21. Notice that in each of these cases I'm not jumping from the original problem clear down to the answer. I'm taking this step right here because what this lets me do is it lets me count the terms. Here's 1 term, 2 terms, 3 terms, and 4 terms. That way I'm sure that I got every single one of them. If I'm multiplying a binomial times a binomial, I should have 4 terms total, and then they might combine to make 2 terms or 3 terms or 4 terms. But all in all, I know that I should end up with 4 terms in this step right here. That's a way that I can check to make sure that I'm doing it correctly. For people who are more visual, there's a third method that works. I personally don't like the FOIL method because it's really only useful for multiplying a binomial times a binomial, only useful when you get 4 terms. There's another way of doing this that will work for any polynomial times any other polynomial, and it's called the tableau method. Tableau is just French for table, and it's what it sounds like. We're going to actually make a table for this. So what I'm going to do is I'm going to make what looks kind of like a tic-tac-toe board. We gotta leave a little bit of space. And this way is a little slow at first if you haven't done it before, but here's the gist of it. One of these polynomials I'm going to have going across the top. The other polynomial I'm going to have going straight up and down. So I'm going to take this 4x squared. That's my first term. I'm going to put it in this first slot right here. I'm skipping this space because it's going to turn out like a multiplication sign, like a multiplication table. And then I take this negative 7 right here and I put it in that second slot right there. Now I take this 5x squared and I put it right here, and this plus 3 I put right here. So now what I do is I treat this like a multiplication table. Going downward, I've got this, and if I make these two meet up, this 4x squared and this 5x squared, those will meet in this box right here. So I multiply those two together and I put the product in this box right here, 20x to the fourth. Then I can do the same thing with another one of my terms, and I can treat this like a multiplication table. I don't need to fill it in all at once. I could jump straight down here to this box, but let's go in the order that we've been going in. 4x squared I'm going to multiply by 3, and that's going to go in this box. That's where these guys meet. So 12x squared. These guys meet in this box. Negative 35x squared, that's negative 7 times 5x squared, negative 35x squared, and negative 7 times 3 would give me a negative 21. Now all I have to do is just add all of these together. 20x to the fourth. I have a plus 12x squared. I'm adding a negative or subtracting 35x squared, and then I'm adding a negative 21 or subtracting 21, and then I simplify this again. Oops. Negative 23 x squared minus 21. So we've got three methods that we can use. First one is just viewing this as distributive property, multiply this term, the first term times every one of these terms, multiply the second term times every one of these terms, and if I had a third term, then I could do that as well. That's the first method. Second method was the FOIL method. First, outer, inner, and last. Helps me keep track, and it's only useful for a binomial times another binomial. And then the tableau method, which is more like a multiplication table and works well for visual learners. You just put one of the polynomials up top, one of the polynomials vertically, and then you treat it like a times table, add all the results together, and simplify at the very end. Now, here's the problem with FOIL, and here's the reason why I don't like doing it. Let's say we have x squared plus 2x plus 1 times 3x minus 4. I can very easily multiply x squared times both of these, 2x by both of these, 2x times 3x and 2x times negative 4, 1 times 3 and 1 times negative 4, add them all together, and that's what I get. I can also set this up pretty easily by using the tableau method. X squared, 2x, and 1. That's the top part. And then the bottom, going downward, 3x and negative 4. I can fill this out. It just has another column right here, and I can keep on adding columns the more numbers I have. However, the FOIL method doesn't work, because if I say the first makes sense. First would be x squared times 3x. But when I say, and I suppose outer works also. I could do the outer and the outer. But the inner, there's more than one inner in here. So that's a problem. And if I only have 4 letters for my